Before we go in to learn how to write the chemical formula of a compound, we need to know another important term in chemistry. That is a radical. Now what is a radical? Radical is an atom or a group of atoms of different elements which behave as a single unit carrying a charge, that is either a positive charge or a negative charge. Here you can see an example of a radical. This is called as hydroxide radical, which is represented as OH minus. Here it is the group of atoms of different elements, that is the element oxygen and the element hydrogen, and it behaves as a single unit carrying a charge. That is, in this case, it is a negative charge. In case of hydroxide radical, it carries a negative charge. Now, I have already told you, in order to know how to write a chemical formula of a compound, we need to know two important things. First one is the symbol of an element. Then second one is the combining capacity or the valency of an element. We have already learned what is the symbol of various elements. Now let us have a quick look at those symbols which we have already learned. Symbols of metals and symbols of various non-metals. Symbol for the metal potassium is K, sodium Na. For the element calcium, the symbol is Ca. For the element magnesium, symbol is Mg. For zinc, Zn. Aluminium, Al. For the non-metals like chlorine, the symbol is Cl. For the element bromine, Br. For the non-metal iodine, I. Oxygen with the symbol O. Sulfur with the symbol S. And carbon with the symbol C. Now we will see the symbols of radicals. Nitrate has got a symbol NO3. Hydroxide radical has got a symbol OH. We have already taken that example here in order to explain radical. Sulfite has got the symbol SO3. Sulfate SO4. And for the carbonate radical, the symbol is CO3. Now we will see the combining capacity or the valencies of various elements. Valencies are of two different types, that is a positive valency and a negative valency. Generally, most of the metallic elements will have a positive valency and non-metallic elements will have a negative valency. For the element potassium, which is a metal, it has got a positive valency and the valency is 1. For the element sodium, which is again a metal, has got a positive valency and it has got a valency of 1. For the element calcium, which is a metal, the valency is 2. For zinc, the valency is again 2. For aluminium, which is again a metal with a positive valency, and the valency is 3. Now in case of non-metallic elements, it will have negative valency. For the element chlorine, which is a non-metal, it has got a negative valency and the valency of chlorine is 1. For the element oxygen, again it has got a negative valency and the valency of oxygen is 2. For the element sulfur, since it is a non-metal, it has got a negative valency and the valency of the element sulfur is 2. We will see the valencies of radicals, that is nitrate. It has got a valency of 1, which is a negative valency. For hydroxide, we have already seen it has got a valency of 1, which is again a negative valency. For sulfate radical, a negative valency and the valency of sulfate radical is 2. For carbonate radical, again this also has got a negative valency and it has got a valency of 2. So now you have understood what are the symbols of various elements. And you have also seen the valencies of various elements, that is metals and non-metals. Also, we have understood the valencies of radicals. So with this understanding, now we are going to see how we can write a chemical formula of a compound. So in order to write the chemical formula of a compound, we need to follow three important steps in this order. So the first step is write the symbol of the element with its combining capacity. The second step is interchange the combining capacity of the element, or otherwise the valency of the element or radical. And the third step is write the interchanged number, and hence we will derive at the formula. Now let us understand this by taking two examples. The first one is sodium chloride. Now we know that the chemical formula of sodium chloride is NaCl. Now let us see how we will derive with this formula NaCl. What is the first step? We need to write the symbol of the element with its combining capacity. So the elements that are present in the compound sodium chloride is sodium and chlorine. Now since we need to write the symbol of the elements, yes, for sodium the symbol is Na, for chlorine the symbol is Cl. Now we have to write it with the combining capacity. Therefore, we have already studied the valency or the combining capacity of sodium is 1, and the combining capacity or the valency of chlorine is again 1. But in case of sodium, which is a metal, therefore it has got a positive valency. But chlorine, which is a non-metal, will have a negative valency. And therefore, in step 1, we will write the symbol of the element with its combining capacity here as Na plus 1 and Cl minus 1. Now what is the second step? We have to interchange the combining capacities of the element or the valency of the element or radical. So for that, we have to write the valency of each of these elements under the symbol that is given for the element. So the valency of sodium here is 1, and the valency of chlorine is again 1. Remember that we are not writing these charges here when we write the valencies. So for sodium, the valency is 1, and for chlorine, the valency is 1. Now we are going to interchange the combining capacity of the element or the valency of that element. Now this 1, which is the valency of sodium, will go for chlorine, and it will come as a subscript here next to chlorine. And this 1, which is the valency of chlorine, will go for sodium, and it will come as a subscript next to sodium. And therefore, we write it as Na1 and Cl1. Now, what is the third step? We have to write the interchanged number and finally derive at the formula. Now, how do we write this interchanged number? These two we are going to combine. That is Na1 and Cl1. So, we are writing it together, these interchanged numbers, as Na1, Cl1. And finally, since it is 1 here, we have already seen in the previous slide, when it is 1 as the subscript, we are going to ignore that 1. And therefore, we are going to derive at the formula of this chemical compound sodium chloride. Ignoring this 1, we write it as NaCl. Now, in order to understand this better, let us take one more example. Now, we are going to derive the chemical formula of the compound zinc chloride. Now, what is the first step? We have to write the symbol of the element with its combining capacity or the valency of that elements. So, we know that for the compound zinc chloride, the elements that are present are zinc and chlorine. So, now we need to write the symbols of these elements. The symbol for zinc is Zn, and the symbol for chlorine is Cl. But we have to write it along with the combining capacity of those elements. Now the combining capacity of zinc, we have already seen that it is 2. Since zinc is a metal, it has got a positive valency. Now the combining capacity or the valency of chlorine, which is a non-metal, is 1, and since it is a non-metal, it has got a negative valency. Therefore, we write it as Zn plus 2 and Cl minus 1. Now what is the second step? We have to interchange the combining capacity or the valencies of these elements. Now we have already seen that the valency of zinc is 2. So now we are writing that 2 without the charge here. Now we know that the valency of chlorine is 1. So again we are writing that 1 here without the charge here. Now we are going to interchange these valencies. So now 1, which is the valency of chlorine, will go for zinc and it will come as a subscript near to zinc. And 2, which is the valency of zinc, will go for chlorine and it will come as a subscript for chlorine next to chlorine. And therefore, we are writing now the interchanged number and it will come as Zn1 and Cl2. Now, I have already told you, whenever there is a 1 that is present as a subscript next to any of these symbols of the elements, we need to ignore that 1. And therefore, we derive at the final formula of the compound zinc chloride as ZnCl2. Now with this, I hope that you have got an understanding of how to derive a chemical formula of a compound.